Picture this. You're sitting in your living room, and in the space of a single heartbeat, a message travels from Earth to a distant star and back again. Not in years, not in decades, but instantaneously. It sounds like science fiction, but physicists have discovered that if we could somehow achieve faster than light travel, we wouldn't just be bending the rules of physics, we'd be unraveling the very fabric of cause and effect, potentially destroying the logical foundation that holds reality together. Welcome back to this quiet corner of the universe, where we explore the deepest mysteries of existence. I'm here with you tonight, and whether you're settling into bed, taking a peaceful walk, or simply letting your mind wander, we're about to embark on a gentle journey into one of the most profound questions in all of physics. Tonight, we're asking not whether faster than light travel is possible, but what would happen to reality itself if it were. Before we drift deeper into this cosmic mystery, I'd love to know where you're listening from tonight. Are you watching from a cozy apartment in Tokyo as the city lights twinkle below? Perhaps you're in a quiet cabin in the mountains of Colorado, with snow falling softly outside your window. Drop a comment and let me know where this journey finds you. Your presence here, wherever you are, adds something beautiful to this shared exploration of the unknown. Now settle in, get comfortable. You don't need to remember every detail or take notes. Just let these ideas wash over you like gentle waves, each one carrying us deeper into the mystery of what it means to exist in a universe bound by the speed of light. There's something almost poetic about light. It doesn't hurry, yet it never slows down. It travels at exactly 299,792,458 meters per second through the vacuum of space, neither faster nor slower, as if the universe itself had decided this was the perfect pace for information to flow across the cosmos. But this isn't just any speed limit. This is the speed limit, the fundamental boundary that shapes everything we know about reality. Albert Einstein discovered this over a century ago, and what he found wasn't just a rule about how fast things can go. He uncovered something far more profound. The speed of light is woven into the very structure of existence itself. Think about it this way. Right now, as you listen to these words, light from your screen or the room around you is bouncing into your eyes at this cosmic speed limit. The electricity powering your device moves through the circuits at a significant fraction of light speed. Even the chemical signals in your neurons, the very thoughts processing these ideas, are bound by electromagnetic forces that respect this universal constant. Einstein realized that as objects approach the speed of light, something extraordinary happens. They don't just get harder to push faster, as you might expect. Instead, their mass begins to increase. Not in the sense that they gain more particles, but in a more fundamental way. The very property we call mass, the resistance to acceleration, grows larger and larger as speed increases. Imagine trying to push a shopping cart that becomes heavier the faster it moves. At first it's easy enough. Push a little harder and it speeds up. But as it approaches some critical speed, the cart becomes increasingly massive. Push harder still, and it becomes more massive yet. By the time you're approaching that critical speed, the cart has become so heavy that it would take infinite force to push it just a tiny bit faster. This is exactly what happens to any object with mass as it approaches light speed. The energy required grows without bound, approaching infinity as the speed approaches that of light. It's not a technological limitation or an engineering challenge. It's the universe itself saying, quite firmly, no. This far and no further. But why? What makes this particular speed so special? The answer lies in something even more fundamental than energy or mass. It lies in the nature of causality itself, the principle that causes must precede their effects. Take a moment here as you listen to consider the simple chain of cause and effect that brought you to this moment. You decided to watch this video, so you clicked on it. That click caused your device to load the content. The loading caused these words to appear or play. Each step follows logically from the last, creating an unbroken chain stretching back through time. This ordering, this fundamental sequence of before and after, is what physicists call causality. And it turns out that the speed of light isn't just about light at all. It's about the maximum speed at which any cause can influence any effect. It's the speed at which causality itself propagates through the universe. Here's where things begin to get beautifully strange. Einstein discovered that what we think of as now isn't the same everywhere in the universe. Time itself is relative, flowing at different rates for observers moving at different speeds. This isn't philosophy or metaphor. It's measurable, testable physics that has been confirmed in countless experiments. Imagine two friends, Sarah and James. Sarah stays on Earth while James travels in a spacecraft at very high speed to a distant star. From Sarah's perspective, watching from Earth, James's clocks run slow. His entire experience of time is stretched out like a piece of taffy. A journey that takes James 1 year might appear to Sarah to take 5 years. But here's the remarkable part. From James's perspective, his clocks run perfectly normally. It's Sarah's clocks, back on Earth, that appear to be running slow. Each observer sees the other's time as dilated, slowed down. This isn't an illusion or a measurement error. It's the actual structure of reality. This relativity of time creates something even more unsettling, the relativity of simultaneity. Events that appear to happen at the same time to one observer might occur in completely different orders to another observer moving at high speed. Picture this scenario. You're standing on a train platform and you see lightning strike 2 points along the tracks at exactly the same moment. The strikes appear perfectly simultaneous to you, but to a passenger on a fast-moving train, these same lightning strikes might appear to happen at different times. The passenger might see the forward strike first, then the rear strike later. Both observations are equally valid. Neither is more correct than the other. The universe doesn't have a universal clock ticking away somewhere, keeping time for everyone. Instead, the experience of simultaneity depends entirely on your frame of reference, your state of motion through space-time. Now, let's scale this up to cosmic distances and consider what happens when we introduce faster-than-light travel into this relativistic universe. Suppose we have a faster-than-light communication system, something that can send messages instantaneously across the galaxy. From Earth, we send a message to Proxima Centauri, our nearest stellar neighbour, about 4 light-years away. The message arrives instantly, faster than light could make the journey. To us on Earth, this seems straightforward. We sent the message first, then it arrived at its destination. But now imagine an observer travelling at very high speed relative to Earth and Proxima Centauri. Due to the relativity of simultaneity, this observer might see the message arriving at Proxima Centauri before it was sent from Earth. From their perspective, the effect has preceded the cause. As you contemplate this idea, notice how it challenges something so fundamental to our experience that we rarely even think about it. The assumption that causes must always come before effects. This isn't just a strange quirk of physics. It's a crack in the foundation of logical reality itself. The implications of faster-than-light travel become even more troubling when we realise that what works for communication also works for travel. If you can send information faster than light, you can, in principle, travel faster than light. And if you can travel faster than light, you can, under certain circumstances, travel backward in time. This isn't science fiction speculation. It's a direct mathematical consequence of Einstein's equations. Faster than light travel in a relativistic universe necessarily implies the possibility of time travel into the past. The classic example is the grandfather paradox. Imagine you could travel back in time and prevent your grandparents from meeting. If they never meet, they never have children, and you're never born. But if you're never born, you can't travel back in time to prevent them from meeting. It's a logical contradiction that seems to tear a hole in the fabric of reality itself. On a cosmic scale, faster than light travel creates similar paradoxes. You could, in principle, send a message to your past self warning about some future disaster. But if your past self acts on that information and prevents the disaster, then there's no disaster to warn about. The message becomes its own contradiction. These aren't just amusing philosophical puzzles. They represent fundamental threats to the logical consistency of the universe. If causes can precede effects, if information can flow backward in time, then the very notion of a coherent, predictable reality begins to break down. It's as though the universe has evolved mechanisms to prevent these paradoxes. The universe speed of light limit isn't just about energy or mass. It's about protecting the causal structure of reality itself. Every photon that reaches your eyes, every electromagnetic wave that carries information, every force that shapes the movement of matter, all respect this fundamental speed limit that keeps cause and effect properly ordered. Think about the elegant simplicity of this cosmic protection system. By making it impossible to exceed light speed, the universe ensures that information cannot travel into the past, that effects cannot precede their causes, and that reality maintains its logical coherence across all possible observers and reference frames. Despite this seemingly ironclad protection, physicists have wondered what would happen if particles existed that naturally travelled faster than light. These hypothetical particles, called tachyons, would live in a mirror world of physics, where faster speeds require less energy, not more. While ordinary particles require infinite energy to reach light speed, tachyons would require infinite energy to slow down to light speed. They would be forever trapped above the cosmic speed limit, just as we are forever trapped below it. It's a fascinating theoretical possibility that opens up even more disturbing implications for causality. The existence of tachyons would create what physicists call a tachyonic anti-telephone. If you could detect and control these faster-than-light particles, you could use them to send messages into the past. But unlike the familiar grandfather paradox involving people, the tachyonic anti-telephone creates causality violations that could propagate throughout spacetime like ripples in a pond. Imagine sending a tachyonic message to your past self with instructions. If you receive this message, don't send it. If you receive the message, you follow the instructions and don't send it. But if you don't send it, then you never receive it. So you do send it. The paradox becomes a temporal loop that has no resolution within the laws of logic. What's particularly unsettling about tachyons is that their existence wouldn't just create isolated paradoxes, they would make the entire concept of causality suspect. If information can flow backward in time through tachyonic channels, then every event becomes potentially its own cause. The arrow of time, the fundamental direction that gives meaning to concepts like memory aging and entropy would become meaningless. Fortunately, there's no evidence that tachyons exist. In fact, quantum field theory suggests that if they did exist, they would make the vacuum of space itself unstable, causing it to decay into a lower energy state in a process that would essentially erase the universe as we know it. Take a breath here and let this sink in. The universe appears to be structured in such a way that faster-than-light particles simply cannot exist without destroying the very foundations of physical reality. It's as if the cosmos has built-in safeguards to protect itself from logical contradictions. But what if there were ways around the light speed limit that didn't involve travelling faster than light through space? What if we could manipulate space itself to create shortcuts or distortions that would allow us to reach distant destinations without technically exceeding the cosmic speed limit? This is where the physics becomes both more hopeful and more terrifying. In 1994, physicist Miguel Alcubierre proposed a theoretical method for faster-than-light travel that wouldn't actually require moving faster than light. Instead, it would involve contracting space in front of a spacecraft and expanding space behind it, creating a warp bubble that would carry the ship along at superluminal speeds. The beauty of the Alcubierre drive is that the spacecraft itself never exceeds light speed relative to the space immediately around it. It's the space itself that's moving, carrying the ship like a surfer riding a wave. From the perspective of someone inside the warp bubble, they're barely moving at all. They're simply being carried along by the flow of distorted space-time. It sounds like the perfect loophole. We could reach distant stars without breaking Einstein's speed limit, without violating causality, without destroying the logical structure of reality. But as physicists began to examine the Alcubierre drive more carefully, they discovered that the cure might be worse than the disease. The energy requirements are staggering. To create a warp bubble large enough to enclose a modest spacecraft would require more exotic matter than exists in the observable universe. And this isn't ordinary matter we're talking about. The Alcubierre drive requires matter with negative energy density, a substance so exotic that it may not be able to exist in stable form. But even if we could somehow solve the energy problem, we'd still face the causality issue. Detailed calculations show that Alcubierre warp bubbles could be used to create closed time-like curves, paths through space-time that loop back on themselves and allow travel into the past. Once again, faster than light travel, even through this seemingly clever workaround, leads us straight back to the spectre of causality violation. As you listen to this, notice how the universe seems almost cunningly designed to prevent any form of faster-than-light travel. Every apparent loophole leads either to impossible energy requirements or to causality violations that would undermine the logical foundation of existence itself. The same pattern emerges when we consider wormholes, those hypothetical tunnels through space-time that could connect distant regions of the universe. While mathematically possible solutions to Einstein's equations, traversable wormholes require exotic matter with negative energy to remain stable. Without such matter, they would collapse faster than light could cross them, making them useless for travel. Even if we could create and stabilize a wormhole, we'd face the same temporal paradoxes. Wormholes could theoretically be manipulated to create time machines, allowing travel into the past with all the associated causality violations that would entail. It's beginning to seem as if the universe has a kind of cosmic censorship principle at work, preventing not just faster than light travel, but any phenomenon that would allow information or matter to violate the causal structure of space-time, reality appears to be protecting itself from logical contradictions with the same determination that a living organism protects itself from toxins. There is one phenomenon in physics that seems to violate the light speed limit, and it's happening all around us, all the time. Quantum entanglement allows particles to influence each other instantaneously across arbitrary distances, seemingly faster than any signal could travel between them. When two particles become entangled, measuring one immediately determines the state of the other, no matter how far apart they are. Einstein called this spooky action at a distance and was deeply troubled by its implications for his theory of relativity. If information could travel faster than light through quantum channels, wouldn't this violate causality just as surely as faster than light particles or warp drives? The answer is both yes and no, and the resolution reveals something profound about the nature of information and causality. While entangled particles do influence each other instantaneously, this influence cannot be used to transmit information faster than light. Here's why. When you measure an entangled particle, you get a random result. You have no control over whether your measure spin up or spin down, polarization left or right. The measurement of the distant partner will be correlated with your result, but since your result is random, you can't use it to send a coded message. It's like having two coins that are magically synchronized. When one comes up heads, the other always comes up tails. But since you can't control which way your coin lands, you can't use this synchronization to communicate with someone holding the other coin. Quantum entanglement demonstrates non-local correlations without allowing non-local communication. The universe has found a way to permit these mysterious quantum connections while still protecting the causal structure that prevents information from travelling into the past. This is perhaps the most elegant example of the universe's apparent commitment to protecting causality. Even in the quantum realm, where particles can exist in multiple states simultaneously and reality itself seems fluid and uncertain, the fundamental principle that prevents logical paradoxes remains intact. There's another place in the universe where the speed of light reveals its deepest mysteries, and it's perhaps the most extreme environment we know of, the event horizon of a black hole. Here at the boundary between existence and oblivion, the relationship between information, causality, and the speed of light creates puzzles that have haunted physicists for decades. Imagine you're watching a friend fall toward a black hole. As they approach the event horizon, something strange happens. From your perspective, safely distant from the gravitational monster, your friend appears to slow down. Their movements become sluggish, their clocks tick more and more slowly, and their image becomes increasingly red-shifted until it fades to infrared and then radio waves. To you, it looks as if your friend never quite crosses the event horizon. They seem frozen at that boundary, their final moments stretched across eternity. But from your friend's perspective, assuming they could somehow survive the tidal forces, they would cross the event horizon in finite time and continue falling toward the singularity at the black hole's centre. This isn't just a curiosity about extreme gravity. It reveals something profound about the nature of information in our universe. According to quantum mechanics, information cannot be destroyed. Every particle, every interaction, every quantum state must leave some trace in the universe's quantum mechanical description. This principle, known as unitarity, is as fundamental to quantum mechanics as the conservation of energy is to classical physics. But black holes seem to violate this principle. When matter falls past an event horizon, it appears to disappear from the universe forever. taking its quantum information with it. When the black hole eventually evaporates through Hawking radiation, that information seems to be lost permanently, creating what physicists call the information paradox. The resolution of this paradox may lie in understanding that the speed of light isn't just a limit on motion through space, but a fundamental limit on the flow of information through the universe. Some interpretations suggest that the information falling into a black hole is somehow encoded on the event horizon itself, preserved in a two-dimensional holographic record even as the three-dimensional matter disappears. As you contemplate this idea, notice how it challenges our intuitive understanding of three-dimensional space. The holographic principle suggests that all the information contained in a volume of space can be encoded on its two-dimensional boundary, much like a hologram encodes a three-dimensional image on a flat surface. This principle has profound implications that extend far beyond black holes. Some physicists speculate that our entire three-dimensional reality might be a holographic projection from information encoded on a distant two-dimensional surface. If true, this would mean that the fundamental reality is not the space we experience, but the information that describes it. The speed of light, in this view, becomes not just a limit on how fast objects can move, but a limit on how quickly information can be processed and updated throughout this cosmic hologram. Faster than light travel wouldn't just violate causality, it would potentially corrupt the very information processing system that maintains the coherent experience we call reality. Some physicists have proposed an elegant solution to the causality problems created by faster-than-light travel. Perhaps causality violations don't destroy reality, but instead create new realities. In the many worlds interpretation of quantum mechanics, every quantum measurement creates a branching of the universe into multiple parallel realities, each representing a different possible outcome. Could faster-than-light travel work similarly? Perhaps when you send that message to your past self, you don't create a paradox within a single timeline, but instead create a new branch of reality where the events unfold differently. Your past self receives the message and acts on it, but this creates a new timeline rather than altering the original one. It's a seductive idea that seems to solve the grandfather paradox and all its cosmic variations. Travel back in time and prevent your grandparents from meeting. You simply create a new timeline where you were never born, while the original timeline where you were born continues to exist in parallel. But this solution comes with its own troubling implications. If every causality violation creates new universes, then faster-than-light travel becomes a universe-generating machine. Every message sent into the past, every temporal loop, every causal paradox would spawn countless new realities, multiplying existence itself at an exponential rate. Consider what this means on a cosmic scale. If advanced civilizations throughout the universe developed faster than light technology, they would be constantly creating new universes through their causal violations. The multiverse would become an ever-expanding foam of realities, each spawned by someone's attempt to circumvent the speed of light. More unsettling still is the question of which reality you would experience. If you send a message to your past self and create a new timeline, do you remain in the original timeline, or do you somehow shift to the new one? The mathematics of many worlds quantum mechanics doesn't provide a clear answer, leaving us with a kind of existential uncertainty about the nature of personal identity across multiple realities. Take a moment here to consider how this multiplicity of realities might affect the meaning of choice and consequence. If every decision creates new universes where different choices are made, does any individual choice really matter? Or does the existence of infinite parallel selves somehow diminish the significance of this particular self, in this particular moment, listening to these particular words? The space around you right now, the seemingly empty air between your device and your eyes, is actually seething with invisible activity. The quantum vacuum, as physicists call it, is not truly empty, but filled with virtual particles constantly popping into existence and annihilating each other in time frames so brief they barely qualify as existence at all. These virtual particles respect the speed of light limit, but they do something even more interesting. They create a kind of background resistance to anything that tries to move through space. This resistance, known as vacuum drag, might be one of the fundamental reasons why the speed of light represents such an absolute barrier. Imagine trying to swim through water that becomes denser the faster you move. At slow speeds, the resistance is negligible, but as you approach some critical velocity, the water becomes so thick that it would take infinite force to push through it any faster. This is analogous to how the quantum vacuum might resist faster than light motion. The energy stored in these quantum fluctuations is staggering. Calculations suggest that every cubic centimetre of empty space contains enough vacuum energy to power human civilization for billions of years, if we could somehow tap into it. But this energy is locked away in the quantum foam, accessible only through the most exotic physics. Some theories propose that faster than light travel might be possible by manipulating these vacuum energies, essentially creating regions of space with different properties than the normal vacuum. But every proposed mechanism runs into the same fundamental problem. The energy requirements are so enormous that they would require more mass energy than exists in the observable universe. It's as if the universe has encrypted the key to faster than light travel in the quantum vacuum itself, but the password requires more information than the universe contains. Every theoretical pathway to exceeding light speed demands resources that exceed the total budget of reality. As we explore these deep questions about the nature of reality and the speed of light, we inevitably encounter one of the most mysterious aspects of existence: consciousness itself. Some interpretations suggest that consciousness plays a fundamental role in quantum mechanics, collapsing wave functions and determining which of many possible realities we experience. If consciousness does interact with the quantum realm in some way, could it provide a pathway around the light speed limit? Could the instantaneous nature of conscious experience somehow transcend the constraints that bind matter and energy? This remains highly speculative, and no scientific consensus exists about any direct connection between consciousness and quantum mechanics. However, the question itself reveals something important about our relationship with the cosmic speed limit. We are, after all, conscious beings embedded in a universe that seems designed to prevent faster than light travel. Consider the strange fact that consciousness appears to operate outside the normal flow of time in some respects. In dreams, we can experience events in any order. In memory, we can revisit the past instantaneously. In imagination, we can project ourselves into possible futures without regard for the speed of light. Yet these mental travels don't violate causality because they don't carry information that could affect the physical world in paradoxical ways. They remain within the realm of subjective experience, safely quarantined from the objective reality where causes must precede effects. As you reflect on your own conscious experience right now, Notice how your thoughts can jump instantly between ideas, memories, and possibilities. Your mind can contemplate the edge of a black hole, then shift to wondering what you'll have for breakfast tomorrow, then return to puzzling over the nature of time itself. This mental faster-than-light travel is perhaps the only form that the universe permits without destroying causality. Why does the universe seem so carefully designed to prevent faster-than-light travel? One possibility is that universes allowing such travel simply cannot sustain the kind of complex, stable structures necessary for the emergence of conscious observers like ourselves. This is an application of the anthropic principle, the idea that the universe appears fine-tuned for life because we can only observe universes in which observers can exist. Perhaps faster-than-light travel is incompatible with the development of stars, planets, chemistry, and biology. Think about it this way. If causality could be violated freely, if information could flow backward in time without constraint, could the stable patterns we call atoms still exist? Could the chemical reactions that power life proceed reliably? Could the electromagnetic forces that hold molecules together maintain their consistency? The universe might be a delicate balance between allowing enough quantum uncertainty to enable complexity and creativity, while maintaining enough causal stability to prevent logical contradictions from tearing reality apart. The speed of light could be the cosmic compromise that makes existence possible. Some cosmologists speculate that there might be other universes, perhaps with different values for the speed of light or different relationships between space, time, and causality. But we can only observe this universe, the one where the speed limit happens to be exactly what's needed to allow stars to shine, planets to form, and consciousness to emerge and wonder about its own existence. There's something profoundly beautiful about living in a universe with limits. The speed of light doesn't just constrain our ability to explore the cosmos, it creates the very structure that makes exploration meaningful. Without the light speed limit, there would be no discrete events, no clear sequence of cause and effect, no stable framework within which stories could unfold. The speed of light gives shape to time itself, creating the arrow of causality that allows the present to emerge from the past and give birth to the future. Consider how different existence would be in a universe without this limit. Every moment would be connected to every other moment. Past, present, and future would blend into an eternal, timeless now. There would be no growth, no change, no development from simpler to more complex states. The very concept of experience, of learning, of becoming, depends on the ordered flow of time that the speed of light protects. In constraining us, the cosmic speed limit also creates possibility. Because information cannot travel faster than light, distant parts of the universe can evolve independently, creating diversity and novelty. Because causes must precede effects, complex systems can build upon simpler ones, without the risk of logical contradiction, destroying their foundations. As you sit here now, contemplating these ideas, you're participating in one of the universe's most remarkable achievements. A conscious mind emerged from matter, capable of understanding its own constraints and finding beauty in limitation itself. This is only possible because the universe maintains the stable causal structure that the speed of light protects. The speed of light isn't a prison that confines us to our local corner of space-time. It's the foundation that makes consciousness, creativity, and comprehension possible in the first place. Without it, there would be no us to be confined, no thoughts to think, no mysteries to contemplate. Here's something that might surprise you. The empty space between atoms in your body weighs more than the atoms themselves. The quantum vacuum, that restless sea of virtual particles flickering in and out of existence, carries an energy density so immense that a single coffee cup of truly empty space would contain enough power to boil away Earth's oceans. Yet this incredible energy remains perfectly hidden, locked away in quantum fluctuations that exist for time frames shorter than the smallest measurement we can make. It's as if the universe has buried an infinite treasure chest in plain sight, but encrypted the lock with mathematics so complex that opening it would require more energy than the treasure contains. This paradox reveals something profound about the relationship between faster-than-light travel and the fundamental structure of reality. The quantum vacuum isn't just empty space with some interesting properties. It might be the very mechanism that enforces the cosmic speed limit, creating an increasingly dense resistance to anything that tries to exceed light speed. Think of it like swimming through water that becomes thicker the faster you move. At ordinary speeds, you barely notice the resistance. But as you approach some critical velocity, the water transforms from liquid to syrup, then to concrete, requiring exponentially more force to push through. The quantum vacuum might work similarly, its virtual particles creating a drag force that becomes infinite at the speed of light. As you contemplate this idea, notice how it transforms our understanding of what emptiness means. The space around you isn't vacant territory waiting to be filled. It's an active, dynamic medium that participates in every interaction, every movement, every photon that travels from distant stars to reach your eyes. Recent experiments have detected subtle effects of this vacuum energy. The Casimir effect, for instance, shows that two metal plates placed incredibly close together in a vacuum will be pushed toward each other by the quantum fluctuations of empty space. It's measurable proof that nothingness has substance, that the void itself exerts force. But here's where the story becomes even more intriguing. Some theoretical physicists have proposed that if we could somehow manipulate the quantum vacuum, we might create regions of space with different properties. Imagine creating a bubble where the vacuum energy is lower, essentially making space itself thinner and potentially allowing faster than light travel within that bubble. This isn't pure fantasy. The mathematics of quantum field theory allows for such possibilities, but every calculation leads to the same frustrating conclusion. Creating such a bubble would require more energy than exists in the observable universe. It's as if nature has set the price of breaking the speed limit higher than reality can afford. Deep in the heart of black hole physics lies another clue about why faster-than-light travel might destroy reality. When matter falls past a black hole's event horizon, it creates what some physicists call an information firewall, a boundary where the normal rules of quantum mechanics appear to break down in spectacular fashion. Here's the puzzle. Quantum mechanics demands that information cannot be destroyed. Every particle, every interaction, every quantum state must leave some permanent trace in the universe's mathematical description. But black holes seem to violate this principle catastrophically. When they evaporate through Hawking radiation, they appear to take the information of everything that ever fell into them to an irretrievable grave. The proposed solution is both elegant and terrifying. Some interpretations suggest that the information isn't actually lost, but instead becomes encoded on the black hole's event horizon in a kind of two-dimensional holographic record. From the outside universe's perspective, nothing ever really falls into a black hole. Instead, it becomes smeared across the horizon, its information preserved but scrambled beyond recognition. But this solution creates its own nightmare scenario. If you were to fall toward a black hole, you would encounter what physicists call the firewall paradox. From your perspective, you should be able to cross the event horizon smoothly, experiencing nothing unusual until you reach the central singularity. But if the information preservation theory is correct, you would instead encounter a wall of high-energy radiation at the horizon that would incinerate you instantly. Take a moment to absorb the implications of this idea. The universe might be structured in such a way that the preservation of information takes priority over the consistency of individual experience. Reality protects its quantum mechanical integrity even at the cost of creating paradoxes that seem to violate our most basic assumptions about the continuity of space and time. Now, consider what this might mean for faster-than-light travel. If information cannot be destroyed, and if faster-than-light travel creates scenarios where information could flow backward in time, then perhaps the universe creates its own firewalls to prevent such violations. Maybe the infinite energy requirements for FTL aren't bugs in the physics equations, but features designed to protect the informational integrity of reality itself. The holographic principle suggests something even more radical, that our three-dimensional experience of reality might be a projection from information encoded on a distant two-dimensional surface. If true, then faster-than-light travel wouldn't just violate causality within our space, but could potentially corrupt the very information processing system that maintains the illusion of three-dimensional existence. There's one aspect of faster-than-light phenomena that science struggles to address directly, yet it haunts every discussion of causality and time travel: the nature of consciousness itself. Your awareness right now, as you process these words, seems to operate outside the normal constraints of physics in subtle but profound ways. Consider this: your thoughts can travel instantly between memories of the past and projections of the future. You can contemplate events that happened billions of years ago, imagine scenarios that may never occur, and experience a sense of now that seems to exist outside the flow of time that governs everything else in the universe. No scientific consensus exists about whether consciousness interacts directly with quantum mechanics, but the parallels are intriguing to contemplate. In quantum mechanics, observation appears to play a fundamental role in determining reality. The act of measurement seems to collapse quantum superpositions, forcing particles to choose definite states from a range of possibilities. Some interpretations suggest, metaphorically speaking, that consciousness might operate as a kind of reality selection mechanism, determining which of many possible histories we experience as real. If this were true, then consciousness might already be performing a kind of faster-than-light information processing, instantaneously connecting all possible presents to all possible pasts and futures. But notice how this mental time travel doesn't violate causality in the dangerous way that physical faster-than-light travel would. Your memories of the past can't change the past. Your anticipations of the future can't directly alter future events. Consciousness operates in a realm of information and experience that remains safely quarantined from the physical world where causes must precede effects. This suggests something profound about the relationship between mind and reality. Perhaps consciousness evolved as the one phenomenon that could transcend the speed of light limit without destroying causality, precisely because it operates in the realm of subjective experience rather than objective physical influence. As you reflect on your own awareness right now, notice how it seems to exist in an eternal present that somehow encompasses past and future simultaneously. This timeless quality of consciousness might be our glimpse into what existence would be like without the causal constraints that the speed of light creates and protects. Here's a thought that might keep you awake tonight. What if our entire universe is a computational simulation, and the speed of light represents nothing more than the processing speed of the cosmic computer running our reality? This remains purely speculative, but it offers a fascinating perspective on why faster than light travel might be impossible. In any computer simulation, there's a fundamental limit to how quickly information can be processed and updated throughout the system. The speed of light might be analogous to the clock speed of the universe's central processing unit. If true, then attempts to exceed light speed wouldn't just violate physical laws, they would crash the simulation itself. Faster than light travel would be like asking a computer program to process information faster than its hardware allows, creating system errors that could corrupt the entire virtual reality. Consider how this might explain some of the strange features we've discussed. The infinite energy requirements for FTL travel could be the universe's way of preventing buffer overflow errors. The causality paradoxes could be logical contradictions that the simulation simply cannot resolve without crashing. The quantum vacuum energy we explored earlier might represent the computational overhead required to maintain the illusion of continuous space and time. The universe might be constantly calculating the positions and properties of every particle, every field, every quantum fluctuation, and the enormous energy stored in empty space could be the computational cost of this ongoing reality maintenance. Even more intriguingly, the holographic principle we discussed earlier fits naturally with this computational model. If our three-dimensional reality is indeed projected from information stored on a two-dimensional boundary, this would be exactly what we'd expect from an efficient simulation designed to create the illusion of depth and volume while minimizing computational requirements. Take a breath here and consider how this perspective might change your relationship with the physical world around you. If reality is computational, then the speed of light isn't a constraint on motion through space, but a constraint on the rate at which new information can be incorporated into the universal database that maintains our shared experience. Perhaps the most beautiful way to understand why faster than light travel might destroy reality is to think of space-time as a living ecosystem, delicately balanced and vulnerable to disruption. In any ecosystem, each component plays a role in maintaining the overall stability. Remove one species or introduce an invasive element, and the entire system can collapse in ways that seem disproportionate to the initial change. Space-time might work similarly, with the speed of light serving as a kind of ecological constraint that maintains the balance between causality and complexity. The virtual particles of the quantum vacuum might be like the microorganisms in soil, invisible but essential for maintaining the health of the entire system. The flow of information at light speed might be like the circulation of nutrients, ensuring that all parts of the universe remain connected while preventing any single region from overwhelming the others. Faster than light travel in this metaphor would be like introducing a species with no natural predators into a pristine ecosystem. The immediate effects might seem beneficial, allowing rapid exploration and communication across cosmic distances, but the long-term consequences could be catastrophic, disrupting the delicate balance that allows complex structures like stars, planets, and life to exist. Consider how the arrow of time itself might be maintained by this ecological balance. entropy increases because information flows predominantly in one direction, from past to future, creating the asymmetry that gives meaning to concepts like growth, evolution, and learning. Faster than light travel could reverse this flow, creating pockets of negative entropy that might spread like an infection, ultimately unraveling the thermodynamic processes that power everything from stellar fusion to biological metabolism. As you contemplate this idea, notice how it suggests that our limitations might not be arbitrary restrictions, but essential features that make complexity and consciousness possible. The speed limit doesn't imprison us within a small region of space-time. It creates the stable foundation upon which minds can emerge and wonder about their place in the cosmos. There's an ancient idea, dating back to Pythagoras and other early philosophers, that the universe operates according to mathematical harmonies, like a vast cosmic symphony. Modern physics has revealed this intuition to be remarkably accurate, with the fundamental forces and particles following mathematical relationships of extraordinary elegance and precision. The speed of light might be understood as the tempo of this cosmic music, the fundamental rhythm that keeps all the instruments playing in time. Just as a symphony would collapse into chaos if different sections played at different tempos, reality might lose its coherence if information could propagate at different speeds in different circumstances. Consider how this musical metaphor illuminates the relationship between causality and meaning. In music, harmony emerges from the precise timing relationships between different notes and voices. A chord is beautiful because the frequencies of its component notes relate to each other through simple mathematical ratios. Dissonance occurs when these relationships are disturbed, creating tension that seeks resolution. Causality might work similarly, creating the harmonic structure that allows meaningful patterns to emerge in space-time. Events that are causally connected form consonant relationships, while causality violations would create dissonances that destabilize the entire composition. Faster than light travel would be like trying to play a piece of music where some instruments are rushing ahead while others lag behind. The result wouldn't be a more complex or interesting composition, but a cacophonous noise that destroys any possibility of meaningful pattern or structure. The quantum vacuum fluctuations we've discussed might be like the subtle vibrations of the concert hall itself, providing the resonant medium through which the cosmic symphony propagates. The virtual particles constantly appearing and disappearing might be like the brief grace notes and ornaments that add texture to the main melodic lines. As you listen to these ideas, imagine yourself as both a participant in this cosmic symphony and an audience member capable of appreciating its beauty. Your consciousness might be one of the instruments, contributing its own unique voice to the overall composition while being shaped by the rhythms and harmonies that surround it. Perhaps the most profound insight emerging from our exploration is that the speed of light serves as a kind of cosmic mirror, reflecting back to us the essential nature of existence itself. Every limitation reveals something about what it protects. Every boundary defines what lies within its embrace. The impossibility of faster than light travel doesn't diminish us. It reveals the preciousness of the causal structure that makes our existence possible. Like a gardener who builds walls not to imprison the flowers, but to protect them from destructive winds, the universe maintains its speed limit to preserve the delicate conditions under which consciousness can bloom. Consider how this principle applies to other fundamental limitations. The uncertainty principle in quantum mechanics doesn't represent a failure of measurement techniques, but reveals the intrinsic fuzziness that allows particles to exist in superposition, enabling the quantum processes that power everything from photosynthesis to the neural networks in your brain. The second law of thermodynamics doesn't condemn us to inevitable decay, but creates the energy gradients that drive all interesting processes, from the fusion fires in stars to the metabolic reactions that sustain your thoughts in this moment. Even the finitude of life itself might serve this protective function, creating the urgency and poignancy that gives meaning to conscious experience. An immortal being in a universe without limitations might find existence bland and purposeless, lacking the creative tension that emerges from working within constraints. As you reflect on your own relationship with limitations, notice how they shape and define your experience in ways both obvious and subtle. The fact that you can't be in two places at once creates the uniqueness of your perspective. The fact that you can't know everything creates the joy of discovery. The fact that you can't live forever creates the preciousness of each moment. The speed of light limitation might be the universe's way of ensuring that consciousness remains embodied, localized, and therefore capable of the focused attention that makes deep understanding possible. Without this constraint, awareness might become so diffuse and universal that it loses the capacity for the intimate, personal experience of wonder that you're having right now. As we approach the end of our journey through the implications of faster-than-light travel, it's worth pausing to appreciate a beautiful paradox. The very impossibility of exceeding light speed has driven some of humanity's greatest scientific breakthroughs. Einstein's recognition that nothing could travel faster than light led him to discover the equivalence of mass and energy, revolutionizing our understanding of both matter and space-time. The search for ways around the light speed barrier has driven advances in quantum field theory, general relativity, and our understanding of the fundamental structure of reality. The impossible has always served as a compass for human curiosity, pointing us toward the edges of the known world and inspiring us to push against limitations even when we cannot transcend them. Every attempt to achieve faster-than-light travel has failed, but each failure has revealed new aspects of how the universe actually works. This pattern suggests something profound about the relationship between limitation and creativity. Constraints don't suppress innovation, they channel it in productive directions. The speed of light doesn't prevent us from exploring the cosmos, it shapes how we explore it, encouraging the development of patient, sustainable approaches to understanding our cosmic environment. Consider how this principle might apply to your own creative endeavours. The limitations of language don't prevent poetry, they make it possible by providing structure within which meaning can emerge. The constraints of physical laws don't prevent engineering, they provide the reliable principles upon which technologies can be built. The impossibility of faster-than-light travel might be the universe's way of teaching us that some kinds of transcendence come not from breaking limitations, but from understanding them so deeply that we discover new possibilities within their embrace. As you sit here now contemplating these ideas, you are participating in perhaps the most remarkable phenomenon in the known universe. A conscious mind that has emerged from matter and learned to understand the very constraints that shaped its existence. This understanding doesn't require faster-than-light travel. It happens at the speed of thought, which may be the only speed that truly matters. The universe has given us minds capable of contemplating infinity while remaining anchored in the particular, awareness that can touch the cosmic while staying rooted in the personal. This might be a far more profound achievement than any technology that could carry us instantly across the galaxy. As we drift deeper into this contemplation of reality's deepest structures, there's something almost sacred about the way the universe protects its own logical consistency. Picture causality, not as a rigid law, but as a vast cathedral built from interwoven relationships between events, each moment carefully placed to support the ones that follow. In this cathedral, the speed of light serves as the master architect's most fundamental principle. Every photon that travels from a distant star to your retina, every electromagnetic wave that carries information through your device, every quantum interaction that maintains the atoms in your body, all follow this same universal blueprint. They respect the sacred geometry of cause and effect, ensuring that the cathedral of reality remains standing. Take a moment here, as you listen, to consider the profound trust this represents. The universe trusts its own laws so completely that it makes exceptions for no one and nothing. A photon doesn't travel faster just because it carries urgent information. A gravitational wave doesn't bend spacetime more quickly just because galaxies are colliding. The consistency is absolute, unwavering, beautiful in its reliability. This unwavering consistency creates something unexpected, freedom within constraint. Because the laws are the same everywhere and everywhen, complex patterns can emerge and persist. Stars can burn steadily for billions of years. Planets can maintain stable orbits. Life can evolve, learn, and eventually develop the capacity to contemplate its own existence. Some interpretations suggest that consciousness itself might be one of these emergent patterns, a kind of standing wave in the cathedral of causality that has learned to observe and appreciate the architecture that contains it. If true, then your awareness right now represents the universe becoming conscious of its own logical structure, examining its own foundations with the very consciousness those foundations make possible. Deep within the quantum realm lies something that resembles a monastery of sorts, a place where virtual particles engage in their eternal dance of creation and annihilation, maintaining vows of silence that prevent them from carrying messages faster than light. These quantum monks, if we might call them that, follow rules more strict than any human religious order. They appear in perfectly matched pairs, one positive and one negative, existing for precisely the amount of time allowed by Heisenberg's uncertainty principle before vanishing back into the void. During their brief existence, they influence everything around them, yet they can never be directly observed or communicated with. This quantum monastery fills every cubic centimetre of space around you, an invisible community of particles living at the very edge of existence. They create the background hum of reality itself, the subtle resistance that prevents anything with mass from achieving light speed, the hidden foundation upon which the visible world rests. What's particularly fascinating is how these virtual particles seem to know about the speed of light limitation without ever being able to violate it themselves. They pop into existence already respecting the cosmic speed limit, as if this constraint is written into the very fabric of possibility itself. As you contemplate this invisible community surrounding you, notice how it transforms your understanding of solitude. You're never truly alone. You're always embedded in this quantum monastery, always participating in the subtle interactions that maintain the stability of space and time. The energy these virtual particles carry is staggering beyond imagination. Some calculations suggest that the quantum vacuum contains more energy per cubic centimetre than the total mass energy of all the stars in the observable universe. Yet this energy remains perfectly hidden, accessible only through the most exotic physics, locked away like a treasure that exists but cannot be claimed. This hidden energy might be the universe's insurance policy against causality violations. Any attempt to extract enough energy to power faster than light travel would require manipulating the quantum vacuum in ways that might destabilize the very foundation of reality itself. Information, it turns out, has its own ecology within the universe, complete with conservation laws, predator-prey relationships, and delicate balances that must be maintained for the system to remain stable. The speed of light serves as the fundamental flow rate in this information ecosystem, determining how quickly knowledge can spread from one region of space-time to another. Think of information as a kind of cosmic nutrient, essential for the growth and maintenance of complex structures. Stars require information about gravitational fields to maintain their structure. Planets need information about electromagnetic forces to hold their atoms together. Living systems depend on information flows to coordinate their metabolism and respond to their environment. The speed of light ensures that this information nutrient is distributed evenly throughout the universe, preventing any region from becoming information starved or information poisoned. Just as too much fertilizer can kill a plant, too much information flowing too quickly could overwhelm the delicate quantum processes that maintain the stability of matter itself. Faster than light information transfer would be like introducing an invasive species into this information ecosystem. Initially, it might seem beneficial, allowing rapid communication and coordination across cosmic distances. But the long-term effects could be catastrophic, disrupting the carefully balanced flows that allow complex structures to exist. Consider how this information ecology shapes your own existence right now. The neurons in your brain can only process information at a finite rate, creating the sequential flow of thoughts that gives structure to your conscious experience. If your brain could process information faster than light, would you still have a coherent sense of self? Or would your consciousness become a chaotic blur of simultaneous possibilities? The universe seems to have chosen a processing speed that allows for both complexity and coherence, both diversity and stability. The speed of light might be the optimal flow rate for an information ecosystem, capable of supporting the emergence of consciousness. There's something deeply meditative about the behavior of light itself, the way it travels through the universe with perfect consistency, neither speeding up with excitement nor slowing down with fatigue. Every photon that has ever existed travels at exactly the same speed through vacuum, as if participating in a cosmic meditation that has continued uninterrupted for nearly 14 billion years. This consistency suggests a kind of enlightened detachment from the events light witnesses during its journey. A photon might travel for billions of years, passing through the birth and death of stars, the formation and dissolution of galaxies, the rise and fall of civilizations, yet it never varies. Its pace never allows the drama of existence to disturb its perfect equanimity. From the photon's perspective, if we can imagine such a thing, its entire journey from emission to absorption occurs in zero time. Due to time dilation at light speed, the photon experiences its birth and death as a single, eternal moment. This suggests something profound about the nature of existence at the cosmic speed limit. Perhaps achieving light speed means transcending time altogether. As you reflect on this idea, consider how it might relate to certain meditative states, where the sense of time seems to disappear, where past and future collapse into an eternal present. Some interpretations suggest, metaphorically speaking, that deep contemplative practices might offer glimpses of what existence feels like at the speed of light, where all moments become one moment. But unlike the photon, which achieves this timeless state by having no mass and therefore no choice in the matter, consciousness seems to touch this timeless realm while remaining anchored in the flow of ordinary time. This might be the unique gift of awareness, the ability to experience both temporal and eternal perspectives simultaneously. The speed of light limitation ensures that consciousness remains embodied, localized in space and time, giving it the focused perspective necessary for deep understanding. Without this constraint, awareness might become so diffuse that it loses the capacity for the intimate, personal experience of wonder that you're having right now. One of the most beautiful aspects of the speed of light limitation is its absolute democracy. It applies equally to emperors and peasants, to the largest galaxies and the smallest particles, to the most advanced civilizations and the simplest quantum systems. No amount of wealth, power, or technological sophistication can buy an exemption from this cosmic speed limit. This democratic principle extends throughout physics. The same gravitational constant that determines your weight on Earth also governs the motion of binary pulsars in distant galaxies. The same electromagnetic force that powers your devices also creates the magnetic fields that protect planets from cosmic radiation. The same quantum mechanical principles that make your thoughts possible also determine the behavior of particles in the most remote corners of the universe. This universality suggests something profound about the nature of existence itself. Reality operates according to principles that transcend any individual perspective or local circumstance. The universe is not arbitrary or capricious, but follows rules that can be discovered, understood, and relied upon across all scales of space and time. The speed of light serves as the ultimate expression of this democratic principle. It creates a shared reference frame within which all observers can communicate and compare their experiences. Without this common standard, there would be no possibility for science, no way to verify that the laws discovered in one location apply in another. Take a breath here and notice how this democratic aspect of physical law creates a kind of cosmic citizenship. You are subject to the same fundamental constraints as every other conscious being in the universe, but you also have access to the same fundamental possibilities. The speed of light doesn't discriminate, but neither does it play favorites. This shared limitation creates the possibility for genuine communication and understanding across vast differences in culture, biology, and circumstance. Any intelligent species anywhere in the universe must grapple with the same speed of light constraint, must develop ways of thinking and communicating that respect the causal structure it creates and protects. Perhaps the most counterintuitive insight from our exploration is that limitations often create more possibilities than they eliminate. The speed of light doesn't just prevent certain types of motion, it enables entirely new categories of existence that wouldn't be possible without this constraint. Consider how the finite speed of light creates the phenomenon of horizons, regions of space-time that can influence us but that we cannot influence in return. These horizons aren't barriers that imprison us, they're boundaries that create the possibility for surprise, mystery, and ongoing discovery. Without horizons, the universe would be completely knowable and therefore perhaps completely boring. The light speed limitation also creates the possibility for history itself. Because information takes time to travel, the universe maintains a record of its past in the form of light that is still travelling from distant events. When you look at a star, you see it not as it is, but as it was when the light left its surface. The night sky becomes a vast library of cosmic history, all of it accessible to any observer patient enough to look and listen. Without the speed of light constraint, there would be no such thing as distance in any meaningful sense. Everything would be immediately accessible to everything else, creating a universe without structure, without development, without the possibility for complex patterns to emerge and evolve over time. The speed limit also creates the possibility for privacy and individuality. Because no signal can travel faster than light, different regions of the universe can develop independently, creating diversity and novelty. Your thoughts right now are truly private, not because of any technological limitation, but because of the fundamental structure of space-time itself. As you contemplate your own creative endeavors, notice how constraints shape and enable them rather than simply limiting them. The rules of grammar don't prevent poetry. They make it possible by providing structure within which meaning can emerge. The laws of physics don't prevent engineering. They provide the reliable principles upon which technologies can be built. The impossibility of faster than light travel might be the universe's way of teaching us that some kinds of transcendence come not from breaking limitations, but from understanding them so deeply that we discover new possibilities within their embrace. There's something profoundly patient about a universe that enforces a finite speed limit on all information transfer. It suggests that reality itself operates on a timescale that prioritizes depth over speed, understanding over urgency, wisdom over mere efficiency. Consider how this patience manifests in the larger structures we can observe. Galaxies take hundreds of millions of years to complete a single rotation. Star formation occurs over timescales of millions of years. The evolution of life on Earth has unfolded over billions of years. Even the fastest astronomical events, like supernova or gamma-ray bursts, play out over days or weeks, rather than nanoseconds. This cosmic patience creates space for complexity to emerge gradually, layer upon layer, each new level of organization building upon the stability of the levels beneath it. Atoms form first, then molecules, then larger structures, then planets, then life, then consciousness, then the capacity for conscious beings to contemplate the very processes that brought them into existence. The speed of light limitation ensures that this process cannot be rushed. Information can only flow so fast. Complexity can only emerge so quickly. Understanding can only deepen at the rate allowed by the fundamental constraints of space-time itself. As you listen to these ideas, notice how they might apply to your own process of learning and growth. Deep understanding often requires time for new concepts to settle into your existing framework of knowledge, for connections to form between seemingly unrelated ideas, for insights to emerge gradually rather than being forced. The universe seems to have chosen a pace that allows for both change and stability, both novelty and continuity. The speed of light creates a rhythm that is fast enough to allow interesting things to happen, but slow enough to prevent the chaos that would result from unlimited information flow. This suggests that patience might not just be a virtue for conscious beings, but a fundamental principle of reality itself. The universe is in no hurry to reach any final destination. It seems content to explore possibilities at its own measured pace, savouring each moment of complexity that emerges from the simple rules governing its operation. The uncertainty principle in quantum mechanics creates a fundamental fuzziness that allows particles to exist in superposition, enabling the quantum processes that power everything from stellar fusion to the neural networks in your brain. The second law of thermodynamics creates the energy gradients that drive all interesting processes, from the formation of galaxies to the thoughts you're thinking right now. The finite speed of light weaves through all of these other constraints, creating the temporal structure that allows causes to precede effects, the spatial structure that allows different regions to develop independently, and the informational structure that allows complex patterns to emerge and persist over time. Together, these limitations create what we might call the constitutional framework of reality, the basic rules that make existence possible rather than merely arbitrary. Like the constitution of a nation, these physical laws don't just restrict what can happen, they create the stable foundation upon which everything else can be built. The speed of light serves as perhaps the most fundamental of these constitutional principles, the one that ensures all the others can operate consistently across space and time. Without this cosmic speed limit, the other laws of physics might apply differently in different regions or at different times, making the emergence of stable, complex structures impossible. As you reflect on your own place within this cosmic constitution, notice how your existence depends not just on the presence of these constraints, but on their precise values and relationships. If the speed of light were different, if the uncertainty principle operated differently, if thermodynamics followed different rules, the universe might be unable to support the emergence of consciousness at all. This fine-tuning doesn't necessarily imply design or purpose in any teleological sense, but it does suggest that consciousness and cosmos are intimately connected in ways we're only beginning to understand. We exist not despite the limitations of physics, but because of them, as expressions of the creative possibilities that emerge when simple rules interact over vast scales of space and time. Perhaps the deepest insight from our exploration is that finitude itself might be the greatest gift the universe gives to consciousness. The speed of light limitation doesn't just prevent faster than light travel, it creates the conditions under which awareness, creativity, and meaning can emerge and flourish. In a universe without the speed of light's constraint, where information could flow instantly between any 2 points, there would be no such thing as local experience, no possibility for the focused attention that makes deep understanding possible. Consciousness would become so diffuse and universal that it might lose the capacity for the intimate, personal experience of wonder that you're having right now. The limitation creates what we might call the theatre of awareness, a bounded stage upon which the drama of conscious experience can unfold. Your thoughts, your memories, your hopes and dreams all exist within the protective embrace of this cosmic speed limit, which ensures that your experience remains coherent and meaningful rather than dissolving into chaos. Consider how this principle applies to other aspects of existence. The finitude of life creates the urgency that gives meaning to choices and relationships. The limitations of knowledge create the joy of discovery. The constraints of language create the possibility for poetry and communication. Without the speed of light limitation, the universe might be like a story with no chapters, no paragraphs, no punctuation, just an endless stream of events without structure or meaning. The cosmic speed limit creates the grammar of space-time, the fundamental syntax that allows reality to tell coherent stories about itself. As you sit here now, contemplating these ideas, you are participating in perhaps the most remarkable phenomenon in the known universe, a conscious mind that has emerged from matter and learned to understand the very constraints that shaped its existence. This understanding doesn't require faster than light travel. It happens at the speed of thought, which may be the only speed that truly matters. The universe has given us minds capable of contemplating infinity while remaining anchored in the particular, awareness that can touch the cosmic while staying rooted in the personal. This might be a far more profound achievement than any technology that could carry us instantly across the galaxy. Every attempt to imagine faster than light travel has led us back to the same fundamental insight. Reality is structured in such a way that logical consistency takes priority over unlimited possibility. The universe has chosen coherence over chaos, meaning over mayhem, the sustainable over the spectacular. This choice, if we can call it that, has created a cosmos capable of supporting the emergence of beings who can contemplate their own existence, understand the laws that govern reality, and find beauty in limitation itself. We are the universe's way of understanding itself, consciousness emerging from matter to marvel at the very constraints that made consciousness possible. The impossibility of faster than light travel becomes in this light not a frustration but a gift. It preserves the causal structure that allows stories to unfold, growth to occur, understanding to deepen. It creates the patient, measured pace at which wisdom can emerge from experience. As you prepare to return to your daily life, carrying these insights with you, remember that you are always embedded in this cosmic dance of constraint and possibility. Every breath you take, every thought you think, every moment of awareness you experience is shaped by the same fundamental laws that prevent faster than light travel and thereby make your existence possible. The speed of light serves as a constant reminder that the universe operates according to principles larger than any individual perspective, yet intimate enough to shape every personal experience. In respecting these limitations, we discover not imprisonment, but liberation into a reality rich with meaning, structure, and endless possibility for wonder. The cosmic speed limit doesn't prevent us from touching the infinite. It creates the stable platform from which we can reach toward transcendence while remaining grounded in the particular. And in that reaching, in that eternal dance between the bounded and the boundless, we find perhaps the deepest purpose of conscious existence in a universe where faster than light travel remains forever impossible, and beautifully so. But there's another layer to this cosmic conspiracy against faster than light travel that we haven't fully explored yet, one that reaches into the very frequencies at which reality vibrates. Deep within the quantum foam, there exist what some physicists call forbidden frequencies, energy states that the universe seems to actively prohibit, as if certain notes in the cosmic symphony are permanently out of tune. These forbidden zones aren't just mathematical curiosities. They represent frequencies at which the quantum vacuum itself becomes unstable, where virtual particles can no longer maintain their delicate dance of creation and annihilation. If you could somehow force energy to vibrate at these forbidden frequencies, you wouldn't just achieve faster than light travel, you would potentially unravel the quantum substrate that holds all of reality together. Imagine trying to play a note on a violin string that's tuned so tightly it snaps the moment you touch it. The forbidden frequencies work similarly, except instead of breaking a string, you would be breaking the fundamental harmony that allows matter, energy, space, and time to coexist in stable relationships. Some theoretical calculations suggest that any device capable of generating these forbidden frequencies would require more energy than has existed in our observable universe since the Big Bang. It's as if the cosmos has encrypted the keys to faster than light travel behind an energy barrier that exceeds the total budget of reality itself. As you contemplate this idea, notice how it suggests that the universe might be far more active in protecting its own consistency than we typically imagine. It's not just that faster-than-light travel is difficult or impractical, but that reality itself seems designed to prevent it through multiple overlapping safeguards. The quantum vacuum energy we discussed earlier might serve as one of these safeguards, creating an increasing resistance to motion that approaches infinity at light speed. The forbidden frequencies might represent another layer of protection, ensuring that even if you could somehow overcome the energy barrier, you would encounter fundamental instabilities that make the attempt self-defeating. This creates what physicists sometimes call a conspiracy of constraints, where multiple independent physical principles all work together to prevent the same impossible outcome. It's almost as if the universe has redundant backup systems, like a computer with multiple firewalls, all designed to prevent the same type of system crash. Here's where the story becomes even more intriguing and perhaps a little unsettling. In quantum mechanics, the act of observation plays a fundamental role in determining which of many possible outcomes becomes real. But what if this observer effect extends to the speed of light limitation itself? What if the impossibility of faster-than-light travel is somehow maintained by the presence of conscious observers? This remains highly speculative, and no scientific consensus exists about any direct connection between consciousness and the enforcement of physical laws. However, some interpretations suggest, metaphorically speaking, that the universe might require witnesses to maintain its logical consistency, observers whose presence ensures that causality violations cannot occur. Consider this thought experiment. In a region of spacetime completely devoid of any conscious observers, any measuring devices, any possibility of information being recorded or remembered, could the speed of light limitation still hold? Or does the enforcement of causality require the presence of beings capable of experiencing cause and effect relationships? The question touches on one of the deepest mysteries in physics: the relationship between information, observation, and the fundamental laws of nature. If information cannot be created or destroyed, and if conscious observation plays a role in determining which information becomes real, then consciousness might be more intimately connected to the structure of space-time than we typically assume. Take a breath here and consider how this might transform your understanding of your own role in the cosmic order. You're not just a passive observer of physical laws. You might be an active participant in maintaining the very consistency that makes your existence possible. This suggests something profound about the relationship between mind and cosmos. Perhaps consciousness evolved not just to understand the universe, but to serve as one of the mechanisms by which the universe maintains its own logical coherence. Your awareness right now might be contributing to the cosmic conspiracy that prevents faster-than-light travel and thereby preserves the causal structure of reality. Every attempt to understand faster-than-light travel eventually leads us into what we might call the archaeology of space-time itself, digging through layers of physical law to uncover the foundational principles that govern existence. And at the deepest level we can currently access, we find something unexpected. The universe appears to be constructed from information rather than matter. This isn't science fiction speculation, but a serious interpretation emerging from quantum field theory, black hole physics, and the holographic principle. Some physicists now believe that what we think of as physical reality might be a kind of information processing system, with matter and energy emerging as patterns in an underlying computational substrate. If true, then the speed of light might represent the maximum rate at which this cosmic computer can process updates to reality. Faster than light travel wouldn't just violate physical laws, it would crash the operating system that maintains the coherent experience we call the universe. Think of it like trying to run a software program faster than your computer's processor can handle. The result isn't enhanced performance, but system errors, crashes, and potentially complete data corruption. The universe might be protecting itself from exactly this type of computational overflow by maintaining an absolute limit on information processing speed. This information-based view of reality helps explain some of the strange features we've encountered in our exploration. The quantum vacuum energy might represent the computational overhead required to maintain the illusion of continuous space and time. The virtual particles might be temporary variables in the cosmic calculation, existing just long enough to update the universal database before being garbage collected back into nothingness. Even the holographic principle fits naturally into this computational framework. If our three-dimensional reality is indeed projected from information stored on a two-dimensional boundary, this would be exactly what we'd expect from an efficient simulation designed to create the illusion of depth and volume while minimizing processing requirements. As you reflect on this possibility, notice how it might change your relationship with the physical world around you. The solid objects you can touch, the air you breathe, the light reaching your eyes, all might be manifestations of information patterns in a cosmic computation so vast and sophisticated that it creates the seamless experience of material reality. There's something deeply therapeutic about accepting the impossibility of faster-than-light travel, a kind of cosmic medicine that heals the restless desire to transcend all boundaries and limitations. In a culture obsessed with breaking barriers and exceeding limits, the absolute nature of the speed limit offers a different kind of wisdom. The recognition that some constraints are not obstacles to overcome, but foundations to build upon. The speed of light teaches us that reality itself practices what we might call therapeutic limitation, maintaining boundaries that protect the delicate conditions necessary for consciousness to emerge and flourish. Like a skilled therapist who knows when to set boundaries with a client, the universe maintains constraints that prevent us from destroying ourselves through unlimited power. Consider how this principle manifests in other aspects of existence. The human brain has evolved limitations on memory that prevent us from being overwhelmed by perfect recall of every experience. Our attention has natural constraints that allow us to focus deeply on one thing rather than being scattered across infinite possibilities. Even our lifespan is finite, creating the urgency that gives meaning to our choices and relationships. The impossibility of faster-than-light travel might serve a similar protective function for consciousness on a cosmic scale. Without this limitation, awareness might become so diffuse and universal that it loses the capacity for the focused, intimate experience of being that you're having right now. As you listen to these ideas, take a moment to appreciate the limitations in your own life that you might typically view as frustrating or confining. The need to sleep, which forces you to rest and dream. The need to eat, which connects you to the biological cycles of the planet. The need to breathe, which ties your existence to the rhythm of the atmosphere. Each of these limitations creates possibilities that wouldn't exist without them. Sleep enables memory consolidation and creative insight. Eating connects you to other living beings and to the elements that make up your body. Breathing synchronizes your nervous system and creates opportunities for meditative awareness. The speed of light limitation might work similarly, not confining consciousness, but creating the stable framework within which deep understanding and genuine connection become possible. As we continue to explore the implications of living in a universe with a finite speed limit, we encounter what might be called the philosophy of cosmic patience, a way of being that emerges naturally from accepting rather than fighting against the fundamental constraints of reality. This cosmic patience isn't passive resignation, but active appreciation for the way limitations create space for depth, complexity, and meaning to emerge gradually over time. The universe has been practicing this patience for nearly 14 billion years, allowing stars to form slowly, galaxies to evolve gradually, life to emerge through countless small steps rather than dramatic leaps. The speed of light embodies this patience perfectly. Information can only travel so fast. Complexity can only emerge so quickly. Understanding can only deepen at the rate allowed by the fundamental constraints of space-time itself. There's no rushing the process, no shortcut to transcendence, no way to force faster progress than reality allows. This might seem frustrating to minds conditioned to expect instant gratification, immediate results, rapid solutions to complex problems. But consider how this cosmic patience might actually be a form of profound wisdom, a recognition that some achievements require time to mature, some insights need space to develop, some understanding must be earned through gradual deepening rather than sudden revelation. As you contemplate your own relationship with time and progress, notice how the things you value most deeply often required extended periods of development. Your closest relationships didn't form instantly, but deepened through countless interactions over months or years. Your most meaningful skills weren't acquired overnight, but developed through persistent practice and gradual improvement. The universe seems to have chosen a pace that allows for both change and stability, both novelty and continuity. The speed of light creates a rhythm that is fast enough to allow interesting things to happen, but slow enough to prevent the chaos that would result from unlimited information flow. This suggests that patience might not just be a virtue for conscious beings, but a fundamental principle of reality itself. The cosmos is in no hurry to reach any final destination. It seems content to explore possibilities at its own measured pace, savouring each moment of complexity that emerges from the simple rules governing its operation. Perhaps the most beautiful aspect of the faster-than-light limitation is how it creates intimacy rather than distance, connection rather than separation. By preventing instantaneous communication across cosmic distances, the speed of light ensures that every interaction remains local, personal, immediate in ways that infinite speed could never achieve. Right now, as you listen to these words, you are participating in a fundamentally local event. The electromagnetic waves carrying this information to your ears, the neural impulses processing these ideas in your brain, the quantum interactions maintaining the atoms in your body. All of these happen within the protective bubble created by the speed of light limitation. This locality creates what we might call the intimacy of the present moment, a quality of direct, immediate experience that would be impossible if consciousness could spread instantaneously across infinite distances. The speed limit doesn't separate you from the rest of the universe. It creates the focused awareness that allows you to participate fully in the cosmic dance. Consider how different existence would be in a universe without this limitation. If your consciousness could expand instantly to encompass all of space-time, would you still have the capacity for the intimate, personal experience of wonder that you're having right now? Or would awareness become so diffuse that it loses the ability to appreciate the subtle beauty of a single moment? The impossibility of faster-than-light travel preserves what we might call the sacred locality of consciousness, ensuring that awareness remains embodied, situated, capable of the deep attention that makes understanding possible. Without this constraint, mind might become so universal that it loses touch with the particular, so cosmic that it forgets the personal. Take a moment here to appreciate the exquisite intimacy of your current experience, the unique perspective you have right now. Listening to these particular words at this specific moment has never existed before and will never exist again. This singularity of experience is made possible by the very limitations that prevent consciousness from being everywhere at once. The speed of light creates the theatre of individual awareness, the bounded stage upon which the drama of personal existence unfolds. Your thoughts, memories, hopes and dreams all exist within this protective constraint, which ensures that your experience remains coherent and meaningful rather than dissolving into universal chaos. In a world obsessed with breaking barriers and exceeding limitations, accepting the impossibility of faster-than-light travel represents a profound revolution in thinking, a shift from conquest to collaboration with the fundamental structures of reality. This acceptance doesn't mean giving up on exploration or abandoning the quest for understanding. Instead, it means recognizing that the deepest discoveries often come not from breaking limitations, but from understanding them so thoroughly that new possibilities emerge within their embrace. The history of physics is filled with examples of this principle. When scientists accepted that perpetual motion machines were impossible, they discovered the laws of thermodynamics, which led to the development of more efficient engines and a deeper understanding of energy. When they accepted that you couldn't determine both position and momentum with perfect precision, they discovered quantum mechanics, which revolutionized our understanding of reality itself. The speed of light limitation might work similarly, not as an obstacle to transcendence, but as a doorway to deeper understanding of what transcendence actually means. Perhaps the ultimate journey isn't about traveling faster than light to distant galaxies, but about discovering the infinite depth that exists within the constraints of local experience. This revolution of acceptance transforms our relationship with limitation from adversarial to collaborative. Instead of fighting against constraints, we learn to dance with them, discovering how boundaries create possibilities rather than simply preventing them. As you reflect on your own relationship with limitations, consider how accepting rather than fighting certain constraints might open up new possibilities you haven't yet imagined. The boundaries in your life might not be obstacles to overcome, but invitations to explore more deeply the territory they define and protect. The universe seems to have chosen this collaborative approach to limitation, creating constraints that don't just prevent certain outcomes, but actively enable others. The speed of light doesn't just prevent faster-than-light travel, it creates the causal structure that makes stars, planets, life, and consciousness possible. In any ecosystem, each element plays a role in maintaining the overall health and stability of the system. Remove one species or change one fundamental relationship, and the entire network can shift in unexpected ways. The speed of light serves a similar function in the ecology of consciousness, creating the stable foundation upon which minds can emerge and develop the capacity for wonder. This ecological perspective helps us understand why faster-than-light travel might be not just impossible, but actually harmful to the development of consciousness. Just as introducing an invasive species can disrupt a natural ecosystem, unlimited speed might disrupt the delicate balance of constraints that allows awareness to emerge and flourish. The speed limit creates what ecologists might call a keystone constraint, a limitation so fundamental that removing it would cause the entire system of physical law to reorganize in ways that might not support the complexity necessary for conscious experience. Consider how this ecological metaphor might apply to your own development as a conscious being. The limitations you face, the constraints that shape your experience, might not be arbitrary obstacles but essential elements in the ecosystem of your awareness, creating the conditions under which insight, creativity, and understanding can emerge. Take a breath here and notice how even the simple act of breathing participates in this ecology of wonder. The need to breathe creates a rhythm that synchronizes your nervous system, connects you to the atmosphere of the planet, and provides opportunities for the meditative awareness that allows deep contemplation to occur. Without the constraint of needing to breathe, you might lose this natural rhythm, this built-in invitation to pause, reflect, and connect with the larger systems that sustain your existence. The limitation creates the possibility for a kind of awareness that wouldn't exist without it. Perhaps the deepest insight from our long journey through the implications of faster-than-light travel is that limitations deserve not just acceptance, but gratitude. The speed of light doesn't just prevent certain types of motion, it creates the very possibility for meaning, relationship, and conscious experience to exist at all. This gratitude for limits represents a fundamental shift in perspective, from seeing constraints as problems to be solved to recognizing them as gifts to be appreciated. The universe has given us boundaries not to confine us, but to create the stable framework within which infinite exploration becomes possible. Consider the profound generosity of a cosmos that maintains consistent laws across all of space and time, ensuring that the principles you discover in your local laboratory apply equally to distant galaxies. This consistency creates the possibility for genuine understanding, for knowledge that transcends the limitations of any individual perspective or local circumstance. The speed of light serves as the ultimate expression of this cosmic generosity, creating a shared reference frame within which all conscious beings can participate in the ongoing conversation about the nature of existence. Without this common constraint, there would be no possibility for communication, no way to verify that the insights gained in one location have relevance anywhere else. As you sit here now, contemplating these ideas, you are participating in this cosmic conversation, adding your own unique perspective to the collective understanding that emerges when minds encounter the beautiful mystery of existence within the protective embrace of physical law. The impossibility of faster-than-light travel becomes, in this light, not a frustration, but a profound gift. It preserves the causal structure that allows stories to unfold, relationships to develop, understanding to deepen over time. It creates the patient, measured pace at which wisdom can emerge from experience. Your existence right now, listening to these words, thinking these thoughts, feeling whatever you're feeling, is made possible by the same constraints that prevent faster-than-light travel. The speed limit doesn't separate you from the cosmos. It creates the stable platform from which you can participate fully in the cosmic dance. This conversation has been ongoing for as long as minds have wondered about their place in the cosmos, and it will continue for as long as consciousness exists to ask questions about the nature of reality. Each generation discovers new aspects of the mystery, new implications of living in a universe with such elegant and absolute constraints. The impossibility of faster-than-light travel doesn't end this conversation. It enriches it by providing a stable framework within which meaningful dialogue can occur. The speed limit creates the common ground upon which all conscious beings can meet, regardless of their biology, culture, or location in space-time. You are now part of this eternal conversation, carrying these insights into your daily life, sharing them with others, allowing them to influence how you think about limitation, possibility, and the profound mystery of conscious existence in a lawful universe. The questions we've explored together, the implications we've contemplated, the wonder we've experienced, all of this becomes part of the ongoing dialogue between consciousness and cosmos, mind and matter, the bounded and the boundless. As you prepare to return to your everyday activities, remember that you carry within you the same fundamental constraints that prevent faster-than-light travel and thereby make your existence possible. Every breath you take, every thought you think, every moment of awareness you experience is shaped by these cosmic principles. The speed of light limitation doesn't confine you to a small corner of space-time. It creates the stable foundation from which you can reach toward transcendence while remaining grounded in the particular. And in that reaching, in that eternal dance between the limited and the limitless, you participate in perhaps the most remarkable phenomenon in the known universe. Consciousness contemplating its own existence. The cosmic conversation continues, and your voice is an essential part of it. Whether you're pondering these ideas alone or sharing them with others, whether you're applying them to personal challenges or professional endeavors, whether you're finding comfort in constraints or inspiration in impossibility, you are contributing to the ongoing exploration of what it means to be conscious in a universe governed by the speed of light. There's a profound irony hidden in the mathematics of black holes that reveals something beautiful about the nature of knowledge itself. As you approach a black hole's event horizon, time dilates so dramatically that from your perspective, you would witness the entire future history of the universe unfold in fast forward before you cross that boundary. Yet this ultimate revelation comes at the precise moment when you can no longer share what you've learned with anyone else. This cosmic paradox mirrors something fundamental about consciousness and the speed of light limitation. The deeper we penetrate into understanding the nature of reality, the more we discover that the most profound insights emerge not from transcending limitations, but from exploring them with infinite patience and curiosity. Consider how this applies to your own journey of understanding. The moments of deepest insight in your life likely didn't come from breaking through barriers, but from sitting quietly with questions until they slowly revealed their hidden depths. The speed of light creates a similar invitation to patience, ensuring that knowledge unfolds at a pace that allows genuine comprehension rather than mere information transfer. As you reflect on this idea, notice how it transforms the very concept of learning from acquisition to cultivation. Instead of consuming facts at ever-increasing speeds, true understanding requires the slow fermentation that occurs when ideas have time to interact, connect, and transform within the spacious awareness that limitations create and protect. Every moment of your conscious experience is an archaeological site containing layers upon layers of cosmic history, all of it delivered to your awareness at exactly the speed of light. The photons reaching your eyes began their journey from the sun 8 minutes ago. the light from the nearest star started travelling toward you over 4 years in the past. The glow from distant galaxies carries information from epochs when the universe was young and stars were first learning to shine. This temporal archaeology reveals something profound about the nature of now. What you experience as the present moment is actually a carefully orchestrated symphony of information arriving from different points in cosmic history, all of it travelling at the same fundamental speed and converging in this instant of awareness. Take a breath here and contemplate the extraordinary fact that your present moment experience is literally constructed from light that has been travelling through space for varying amounts of time. You are not experiencing now as a single temporal point, but as a rich tapestry woven from photons that began their journeys at different moments in cosmic history. This understanding transforms the speed of light from a simple physical constant into something more like the fundamental rhythm of conscious experience itself. Without this cosmic speed limit, there would be no coherent now, no stable present moment in which awareness could gather information from across space and time into a unified experience. The impossibility of faster-than-light travel preserves this temporal architecture of consciousness, ensuring that the present moment remains a sacred space where past and future can meet in the eternal dance of awareness, encountering itself through the medium of light. And so here we are at the end of our gentle journey through the cosmic conspiracy that protects reality itself. We've discovered that the speed of light isn't just a number in physics textbooks, but the fundamental heartbeat that keeps existence coherent, meaningful, and beautifully constrained. Every attempt to imagine faster-than-light travel has led us to the same profound truth. The universe has chosen logical consistency over unlimited possibility, coherence over chaos, the sustainable over the spectacular. This choice has created a cosmos capable of supporting minds that can contemplate their own existence and find wonder in the very limitations that make consciousness possible. Tonight, as you drift into sleep, remember that you're travelling at exactly the right speed through space-time. The same constraints that prevent faster-than-light travel are the ones that allow your thoughts to unfold coherently, your memories to remain stable, your awareness to exist as something intimate and precious rather than scattered across infinite possibilities. And if you're curious about how these cosmic insights connect to the most basic and immediate aspects of human experience, I invite you to join me in exploring how the simple, automatic act of breathing might be your personal gateway to the quantum foundations of reality. In our previous journey, You're Breathing Wrong and Blocking Quantum Reality, we discovered how the rhythm of breath might mirror the fundamental oscillations that create and maintain the fabric of existence itself. The speed of light doesn't imprison us within a small corner of the universe. It creates the sacred theatre in which consciousness can emerge, grow, and marvel at the elegant mystery of its own existence. In accepting this limitation, we discover not frustration, but liberation into a reality where every moment is both bounded and infinite, where wonder lives not despite our constraints, but because of them. Sweet dreams, fellow travellers, in this magnificent, perfectly coherent cosmos we call home. Magnificent, perfectly coherent cosmos we call home.